Welcome to the Real Python Podcast. This is episode 142. Have you worked on a project that needed an orchestration tool? How do you define the workflow of an entire data pipeline or a messaging system with Python? This week on the show, Calvin Hendryx-Parker is back to talk about Apache Airflow and orchestrating Python projects. Calvin is the co-founder and CTO of 6 Feet Up and the Python Web Conference co-organizer. He's recently been working on a massive project that requires thousands of jobs involving transferring and transforming data. Through his research into orchestration systems, he found Apache Airflow. Airflow is an open source tool to define, schedule, and monitor workflows. The platform is pure Python and integrates with a wide variety of services. We discuss how workflows are defined by creating Directed Acyclic Graphs, DAGs. Calvin talks about how a recent project outgrew the system and how his team built a clever solution using Python. We also discuss the upcoming Python Web Conference and what virtual attendees can expect. This episode is brought to you by CData Software, the easiest way to connect Python with data, SQL access to more than 250 cloud applications and data sources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Calvin, welcome back.
Hey, it's great to be here, Christopher.
Yeah, I'm very excited to have you on the show again and talk about a couple different things. It sounds like you've been working a lot on large projects and using some tools that I think we could use that might help our Python audience, learn some new ways of doing things with like these sort of big projects.
Yeah, no, definitely.
Do you want to give a little background on maybe the project? Then we could talk about some of the tools and define some terms.
Sure. I mean, we've historically been a Python shop, since almost our inception 23 years ago. And the most recent demand, we've seen a lot of demand actually around big data pipelines. So whether you're going to be doing AI/ML or you've got a data lake or something like that, or a data warehouse where you need to get data, a lot of data, massive amounts of data into a single spot so that it can be then used for analytics or whatever questions the end users want to answer.
Yeah.
That's where a lot of these big data pipelines come into play. So we recently did a large job. It's been about 3 years in the making.
Okay.
For a local health system that they've been acquiring, health system after health system here.
That's
in
the
our
trend,
state.
right?
It is totally, but that produces new kinds of problems, right? Every health system they go acquire, they all had a different system for HR. They all had a different system for medical health records. They had a different
Billing,
system for you name the hundreds of systems that each health system is going to have, and you end up with a giant problem that you have to now pull all this data, normalize it some way, or at least put it into a agreed upon format that the data scientists or the analytics team wants to use, and get it over into your data warehouse in some somewhat expedient fashion. Because some of the times the data they're trying to do these reports on is time sensitive, especially when you're talking about healthcare. A lot of the things they're doing right now, especially when it came to the pandemic, was the processing of COVID data. So they needed to be able to have certain service level agreements with their clients internally to make sure that the data got pulled in centrally, could be reported on, and then published back out inside the organization.
Okay.
And so you're talking about the potential for tens of thousands of tables across thousands of databases, easily when you talk about a group scaling up this large. And that's just the numbers just grow really, really quickly when you start thinking about the fact if you acquire 10 or 100 health systems, and each of those health system has hundreds of databases internally that they all want to pull data from so they can now gather insights and answer questions.
Maybe we could talk about just briefly the format that the data is in. I mean, this is as a general thing. Is it is it relational? Like, are these like systems that are like older SQL based kind of relational database kind of things? Or are you looking at things like the NoSQL, the MongoDBs and such now?
Oh, it's all over the board. I mean, traditionally, a lot of the data is going to be some kind of a relational database, but in their world, it could be flat files. It could be there's databases formats that I had never dealt with because I've never been in the healthcare world.
Yeah,
And
can be specific.
there's some things that are predate SQL. So there's all kinds of craziness. A lot of times those systems are leaving flat file dumps someplace for us to pick up.
Okay.
Some of them are FTP. Some of them may be a REST API call to gather a dump of some kind of data out of a third party system that they don't have control over the database of. So it really ranges.
So those are like reports that were exported out and they run on a schedule or something.
Yeah, or you've got specific kinds of queries where you know how to incrementally get data out of an API and bring it into the system. But by and large, most of it's SQL. There's lots of Oracle databases, lots of MySQL databases, Postgres databases. There's every kind of SQL database probably under the sun is in scope for this kind of a project.
Wow. Yeah. Are you, when you gather it all, are you using anything different? Like, where are you placing it all? Or are you keeping it relational there too?
Oh, no. So in the end, like when you do something like these big data pipelines for these large enterprises, generally you're going to query the data in whatever format it lives in or wherever they've exported it to.
Okay.
Pull that over into a central spot. So typically we have some kind of a landing zone where we will, in this case, they started off or had a existing practice of bringing all the data into one spot as CSV files. So the first, import or transformation is going to be extract the data, bring it into a CSV file, and put it into a storage container. In this case, they're using Azure, but you could use S3, some kind of object store in the cloud, where you now have the ability to have quick access to it. And then you're going to do more operations, transform, fix data types. There's lots of interesting things you'll have to do with the data because sometimes certain databases have certain constraints or limitations and you need to work around those. Like maybe certain ones had limits on the column lengths that you may be able to put data into, and so they've done workarounds by making multiple columns that are just continuations of the data, and so sometimes it's piecing that back together. Sometimes it's like splitting or reformatting or changing the column names. So that's where the rest of the kind of big data pipeline really comes in, is going to be that transformation. That's the T in the ETL of big data pipelines, is going to be that transformation. And not all of them are, and on this project, not many of them were very sophisticated or complicated. It's a lot of like joining stuff, splitting stuff, reformatting stuff, naming stuff, uppercasing stuff, lowercasing stuff. You think of any kind of string transformation or manipulation you would do to data passing through a pipeline, that's kind of what they're doing here.
Okay.
There wasn't a lot of like big calculations where they're pre-calculating a bunch of end results to save some time on the analytics side. That just was not the kind of data they were doing here. But you could imagine a system where you may want to save compute time on the analytics side by pre-computing additional columns, doing that inside your big data pipeline.
Yeah, it sounds like it's like normalizing can mean different things, but sort of standardizing the data, making it all kind of look the same, so it's part of this new like family standard for this large organization. Okay.
Yeah, because if you've got 10 different HR systems and they've all got a different column name for first name, you somehow have to get them all to agree in the data warehouse so that you can query them from an analytics standpoint the same way.
Yeah. When I was working in sort of financial stuff, there were like these systems like Cognos or some of these other kind of tools that were out there that could do this sort of pre-computing you were talking about, that would sort of create somewhat transformed data that was ready, like more ready, for like a data scientist to go at it. But you really are just trying to make sure you have all the raw information ready to go and clean.
Yeah. Oh yeah, totally. And what's interesting is like we've already talked about 3 or 4 big pieces of software.
Yeah.
And just in the short description, we talked about for getting the data from someplace, putting the data in a spot, transferring the data, and then moving it into like the data warehouse. A whole bunch of moving pieces are actually involved in the whole system.
Yeah. Yeah, I had Kyle Stratus on really early on. He's an author at Real Python, and he came on in episode 10, and we were talking about basically being a data engineering sort of person in that role, and how it's different from being a data scientist, and the idea of like the whole ETL process. And so there's some more information there if you want to dig in a little bit about it. And we've had a few other kind of resources, but yeah, it is a unique set of skills, and the almost communication is one of the biggest one, like being able to talk to all these different teams and be able to translate, what they know of their system and make it make sense to you guys who are doing a lot of the programming and building.
Well, and that's what kind of led this group to want to refactor their existing data pipeline, was that the backlog of importing new data sets into the system was just growing. They were never getting ahead of it because they couldn't get the new data sets onboarded fast enough.
Okay.
And some of that was just due to the technology they were using in the past to do this, the communication skills between the people, the formats of the data, and fixing those kinds of things. But what we helped them build in the end was a way to describe their data.
Okay.
Run it, and then take that description. It's technically, we're just using like JSON files to describe the data. So they would have, in our case, like a source smart. So the source of the data, maybe it's an Oracle database someplace. They would describe in JSON files in like a folder, one per table that's in that source that they want to pull over. And that would have like the source columns and then the target columns, and then have some information about the data types that would be in there, and also potentially information about the types of transforms that would need to happen. So now a data engineer doesn't have to be necessarily a full-blown, super senior Python developer to be able to import a new data set into the data warehouse.
Right. You got a lot of definitions.
Yeah.
Kind of ready to go. That's good.
Yeah, and so we helped them build some tooling to point it at a database and build out a skeleton really quickly. Then they can go in and tweak a couple things, and then we built some more tooling around. And we'll talk a little bit about this too, which is Airflow.
Yeah,
Airflow.
I definitely want to dive into that.
Yeah, so Airflow is actually the main orchestrator of this whole like big system. Airflow is telling the various other sub tools like what to go do. Now, Airflow can do a lot of these things, but we really felt like Airflow was an orchestrator first. And so we wanted to leverage it for that main like power. And so building Airflow DAGs, which we'll talk about as well, which is like a directed acyclic graph, is really just a series of tasks.
Yeah.
And they describe how to get through that workflow from the ingest of the data to where it's going to live, when it first enters the system, to how it moves through the transforms, and then where it ends up ultimately in the data warehouse. And that's the Airflow is in charge of that from front to back.
Yeah. So Airflow is an Apache product, Apache Airflow.
Mm-hmm. Yeah.
It's open source.
Mm-hmm.
And I'll just read their like little intro thing. It's for developing, scheduling, and monitoring batch-oriented workflows. It is an extensible Python framework, which is good for us and our audience here, and enables you to build workflows connecting with kind of any technology, is what they're saying.
Yeah.
And they used a couple like workflows as code, dynamic. They're configured as Python code, allowing dynamic pipeline generation. It's extensible, and then it has a lot of flexibility and uses a built-in Jinja templating type of engine. So if you're familiar with Python, you're familiar with a lot of those technologies, this is maybe a good solution for creating large scale or even maybe small scale, like scheduling and monitoring batch-oriented workflows that they save as these DAGs, right?
Right. And if you peek under the covers, it's Django.
Okay. Interesting.
So if you're that was one of the reasons why we picked it up and decided to actually help this project out and use Airflow, is because we've been Django developers for quite a while.
Yeah.
And being able to leverage the understanding of the Django web framework, it really helped us probably get more out of Airflow with less, complicated code, that keep things as simple as possible, and actually be able to do, like you said, like those templates are written in, Jinja, or be able to write our own operators or our own tasks, our own hooks. I mean, one of the big benefits of a tool like Airflow is the fact that it's got a bunch of built-in connectors.
Okay.
So if I want to talk to Oracle, or I want to talk to SQL Server, or I want to talk to, you name it, it's got connectors for doing REST APIs, or talking to Databricks, or talking to, any one of these number of like kind of standard systems that are in the data world. There's already going to be some operators built into connectors, built into Airflow generally to get you started. So it's really easy to get started. It's really quick, especially if you're a Python person, because you do just write your DAG, your set of tasks, as Python.
Okay.
And then you can have, for each set of DAGs, you just write a single Python file in a specific folder. You just drop it in there, and Airflow is constantly watching that folder for new Python files to show up. And as soon as it sees a new one show up in there, it then shows up in your UI on Airflow, allowing you to start running that task or scheduling it, or whatever you want to do to kind of run through that DAG of things to do.
Yeah. They mentioned a bunch of like reasons that they kind of employed Python in this. And they said that it can be stored in version control. And by having version control, you can do rollback and go back to previous versions of different things. They also talk about the ability to develop it with multiple people then simultaneously, like that kind of push-pull thing.
And that's a big concern here, especially when you got a team of people who are trying to run an ETL pipeline across, say, 10,000 tables. 10,000 tables is way beyond the point and click through some web UI to configure your Airflow, your data movements across the big data pipeline. It's just that doesn't scale.
Yeah.
And then when you have to go and debug it and all these kinds of things, there's different kinds of problems that happen when you get beyond just a couple hundred tables. And I think the long tail is where this really is nice because it works well. Is because you've got people who have thousands of tables. At that point, you outgrew all the point and click GUI. The tools that look really great in a demo, don't always work well at this kind of scale.
They're going to fall over.
Oh yeah, big time. And even Airflow has some issues which we had to work around. There's two different ways to write DAGs in Airflow. You've got the Python file, one per DAG that you put in a folder, and Airflow also supports dynamic DAGs, where the DAG itself can produce other DAGs like on the fly. And that's what we originally went down that path, was because all of our DAGs were very, very similar. They change an input, change one or two things here per kind of data maybe you were going to go grab.
Yeah, we were talking about you're generally doing this sort of gathering data job.
Yeah. And it's very, 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 very straightforward. Like our usage of Airflow would look pretty simple from the outside because our DAG is really almost, I think it's just a straight line.
Okay.
It's like ingest, put it to, I'll use a couple jargony words here, like the raw layer, the bronze layer, the silver layer, and then over into the data warehouse. Those are all Delta Lake, Databricks terms. But really that's the whole flow. That's the whole DAG. I described to you like the 6 steps or whatever that are the DAG, but we just have 10,000 of them. And if you want to change, if you change something about that single source of how those 10,000 tables all operate, you don't want to have to go make sure you update 10,000 files in a folder to be able to do that.
Yeah.
The issue though, if on the other side, if you're using the dynamic DAGs with Airflow, it's not going to work. And we ran into that hard wall pretty quickly because the way Airflow reads that DAG folder and reads a dynamic DAG, in behind the scenes under the covers, it goes and basically expands that into those 10,000 files for you in memory. And you will run out of, like, it has a time limit basically where between cycles. And so we were basically, as soon as we got up to like a couple thousand, we would hit that time limit and then DAG generation would fail.
Okay. CData software. Connect, integrate, and automate your data from Python or any other application or tool. At CData, they simplify connectivity between all of the applications and data sources that power business, making it easier to unlock the value of data. Their SQL-based connectors streamline data access, making it easy to access real-time data from on-premise or cloud databases, SaaS, APIs, NoSQL, and big data. Check out cdata.com. That's CDATA.com to learn more. So maybe we should define DAG just briefly. Like we've kind of already talked about this idea that it's a flow. You mentioned probably the simplest kind, which would just be literally like a flow chart that has A pointing to B, pointing to C, pointing to D, and then some endpoint at the very end of that. Mm-hmm. But I guess the main concept with it is that it's part of this mathematic graph theory and computer science stuff where it's a directed graph. There's no cycles. There's no loops.
Right. Nothing. It can't loop back on itself.
Yeah.
So it's always moving forward.
Okay.
if you kind of thought of it, but it has the ability to have, it has a defined beginning, a defined end.
Okay.
But many branching paths in between are also possible. I was mentioning to you earlier before we got on that we actually use Airflow to do some manufacturing plant automation.
Yeah.
And that's one where many branching workflows, because you may have a process happen, the product goes from A to B, but then there's going to be a test. And then depending on the output of that test, you may change C or D or wherever the next step may be, and it may branch you down a different part of the whole acyclic graph, but you all end up at the same end typically.
Yeah. We talked about it briefly about DAGs in sort of the computer science term with Al Swigert. He came on to talk about his recursion book, The Recursive Book of Recursion. And he was talking about, the idea of recursively, traveling through sort of trees. Now, trees are a little bit of different form. They have potentially multiple endpoints, but still the same idea of like, directly, going in there and hopefully, again, not any loops would be the sort of idea. But yeah, it's kind of interesting that is the model that they chose for this, which I guess makes sense. Most sort of jobs that you want to give something should have a defined, beginning point and a defined end point, right? That you're going to give it. And you mentioned a couple different types of jobs that the clients would need, like a manufacturing type of thing. I think some of the examples in their documentation is like messaging types of systems. Potentially could be like emailing or using some kind of tool like Twilio to like message out different things and so forth.
Yeah, and you think about it for like any kind of batch operation, you may have the tasks start, and then as they go along, the various branches happen, and maybe you do need to notify someone that a thing has happened that either was an exceptional behavior, and someone needs to like have a manual intervention into the process,
right?
Or you need to split the data and actually send it down two separate parallel workflows,
depending on their like size or something like that, or...
right? And with Airflow, you can actually have, if you do have that parallel workflows going on, Airflow will actually orchestrate them in parallel. So if you can split up a job in parallel down 5 or 6 different parallel branches, they can all run simultaneously,
and it'll keep track of making sure they're running concurrently. And
yeah, because it's really a lot like a finite state machine. So there's a state to each of the tasks, depending on whether it's like starting up, running, in some kind of exception, or has successfully completed or failed. Each of the if you think about the DAG and having the nodes on that DAG, each of those nodes has their own set of state. And so depending on whether they were successful or failed, they can send down to different branches inside the DAG itself.
Okay. The one thing that I noticed as I was kind of, again, sort of breezing through the documentation and learning a little bit more about it is they had a why not Airflow. And they said Airflow was built for finite batch flows. And I put in parentheses, basically not streaming. Has that come up as a problem for any of the things that you're doing?
It hasn't necessarily. And it's interesting because you can do streaming with Airflow depending on what the other tools you're hooking it up to are. So I mentioned we've used like 3 or 4 different products in this big pipeline, and Airflow can technically do all the things that we did with the other products, but we actually picked some of those other products because they are maybe a little more focused or targeted on that typical domain. So for example, on data ingest, the customer was using a commercial product from Informatica to do ingest out of these various systems. And they were wanting to move into the cloud, and this is a project done on Azure. So we actually moved them over to use Azure Data Factory, which is a pretty slick, UI GUI tool you can kind of point and click through. But we wanted to use Azure Data Factory because it has great connectivity to all these various data sources that were in their realm. Whether it's SQL Server, Oracle, MySQL, JSON, flat files, FTP, REST APIs. Data Factory actually handled those things really well. And technically, you could have used Data Factory for this whole project as well, except I think that scaling point where you get into the thousands of tables is where this gets tricky to manage in just Data Factory only.
Okay.
So having Airflow as the central coordinator talking to Data Factory, telling Data Factory, pick up this data and deposit it over here in this storage container on Azure. And then from there, Airflow now knows that was successful and says the next step of this is pick up those, tell Databricks. So Databricks is another big data tool. And Databricks and Data Factory and like Microsoft Synapse, a lot of these tools are fairly similar in that they wrap functionality around the Spark framework for doing data transformation and big data operations. So under the covers, the Databricks is basically a way to scale Spark across like just big machines, lots of memory. So if you can get all your data sets into memory, you can transform them quickly and then write them out someplace quickly. And it's all about speed and scalability and being able to transform just a ton of data.
Okay.
And so what I mentioned about streaming, Databricks itself supports streaming data sources. So you could actually orchestrate and have Airflow kick off streaming data sources going into Databricks and monitor that flow and status of those jobs and tasks inside of Databricks, and still have Airflow be your orchestrator of streaming data processes.
Right. Starting and stopping them.
Yeah, exactly. Mm-hmm.
Okay. All right.
And handling the exceptional behavior. So if that stream stops or there's some kind of error, what should happen next? Then that's Airflow's real domain.
So when you talked about the project that we kind of started to discuss here, you had initially started out with using individual sort of DAGs, and then you started to use the additional Airflow tool, which I think they call a DAG Factory. Is that right?
Yeah, exactly. That's the dynamic DAGs, like to create a DAG Factory, which we ran into the wall there too.
Right.
So if you probably want to know what the real solution was,
yeah,
right?
Yeah. Well, I guess that's the next step, right? Is like, okay, well, how do you get past that? Because like, how maybe we could briefly talk about like how a DAG Factory would kind of work. Like, I guess the fundamentals. Like, is it constructed slightly differently, or is it like a template, or how does that work?
So the DAG Factory would take in like a configuration file, like a YAML or a JSON configuration file that you would feed to it, and it would generate this giant array of DAGs without the need for templates. So that's kind of the alternative to writing a single file for a DAG and putting in a DAG folder on Airflow. You would just have a single DAG Factory file in there that would instantiate a DAG Factory, read a configuration of some kind, and then it would generate that array of DAGs without the templates.
Okay, and it would just fill up the folder with them.
Well, no, it actually doesn't even fill up the folder. It just does it all in memory, which is where some of the problem comes in with the DAG factories. This works great until you get to thousands. Now, once you get to those thousands, that's when the timeouts were happening, and it would take longer to generate that array of DAGs in memory than the timeout would allow for, because it was getting ready to try and redo it again. So the Airflow is continually watching that folder, looking for changes to DAGs or a DAG factory update. And with the DAG factory, because you're not changing the DAG factory file, you may be changing a YAML file that feeds into the DAG factory. Airflow would have to evaluate it every time it comes around to see if there's been changes to the configuration to know whether it needs to modify that array of DAGs that has been generated.
Wow.
So the middle ground, the thing we actually ended up doing was converting our usage of DAG factories into like smaller, like segmented or sharded versions of those DAG factories, because smaller versions of that can generate quickly.
Okay, and could be held in memory.
It can be held in memory, can be generated quickly, can read faster, can be done in parallel. So being able to kind of split up and shard that DAG factory into maybe one per data source or one per table, depending on the size of those various things, we actually now have a one file. And as you kind of grow these data pipelines and get a little more mature with the deployment of them, you're probably going to run into the need to deploy this as like we use Docker containers, for example, in this case, to make sure that the deployments are consistent, whether we're going from like a dev or a staging environment and then into the production environment.
Okay.
It's the same container. We can reproduce it. We can build the exact same container again at some future date of some past work if we needed to like do a debug, or we can actually pull those containers down and do the debugging on a local developer's laptop really easily.
Right. Not requiring like the whole system.
Right.
Yeah.
And so what we did is at build time of the Airflow containers that we would launch into our Kubernetes cluster, we build out a set of files. So we kind of take the templated one DAG per file approach, but that file is the same contents. It's not actually different contents. They're not different in any way other than we kind of did a little bit of a hack. And there's a blog post on our blog. So if you go to 6up.com, go to the blog, if you search for DAG factories, you'll find this blog post where we talk about how we did this. So based on the name, so we encoded into the name of the file for the Python, the DAG file, the name of the source mart and the name of the table. It has all the files when they get picked up and read by Airflow. We'll look up in the configuration file based on splitting up that file name, understanding which source and which table it's supposed to be for. And now that file, even though it's the exact same copy of the file just thousands of times, it operates differently based on the name of the file, so it knows which source and which table to go get.
Yeah, that's a nice solution. I definitely will include a link to this article in the show notes. And
Right.
it's funny because it's just very much just string logic.
Oh, it is.
Very fundamental Python stuff, but it's like good that you know that. Anybody looking to get into this stuff, it's like, yeah, you can use that as a way of doing it. And then, that naming convention works across the whole different sets of your source marts and your tables in this case.
So you have all the benefits of DAG Factory with all the benefits of the templated DAGs.
Okay.
So you have a central one file that rules them all to build all the DAGs in Airflow. But to get around the scaling problems with Airflow, we just copy the file and use a convention for the file name.
Yeah, nice. Yeah, how long did it take you to come up with it?
Oh, I mean, obviously these things take longer when you're doing it for the first time. I feel like a lot of the things we did on this project were actually pretty novel.
Yeah.
I don't think a lot of folks had done some of these things at this kind of scale. And actually, when I ran into some people at various conferences, I was telling them about what we'd done with Airflow. And they're like, that's impossible. I go, yeah, it is impossible, but we figured out a way around it.
Nice.
So, yeah, I think if we did it again, it'd take a lot shorter time because obviously we figured out what that magic incantation looked like. But it wasn't magic.
Yeah, what your limits were too, right?
Right. Yeah, and knowing where all the sharp edges are, that's all the things you get as being an experienced developer. Is like you learn where you stubbed your toe last time and where the sharp edges are and like what's going to fall over when you do this. Like it's a lot of things it's really hard to instill into a new dev because so much was just like experience and like passed down tribal knowledge. But the thing we have to do as good experienced developers, I feel like, is going to be to write the best documentation possible so that they can kind of experience the story along with you.
Right. And they can kind of, write it as a suspenseful
yeah, right.
thing. Yeah, cool. Can you provide, like, we kind of brushed over some of the other types of things that Airflow could be used for, but I think you kind of started to talk about like one that was more, was it manufacturing? Was that what it was?
Yeah, it's manufacturing.
Okay.
So it's interesting. It's a company that's doing manufacturing and they wanted to replace an in-house homegrown tool that was doing all the orchestration of the various machines on the floor. So when the product starts down the process, they have a code or a custom bespoke application they had all written to do really something similar. Like there was basically equivalents of DAGs, which are just these tasks running in order that had branching depending on conditions. So you'd have exceptional behavior on the factory floor. You'd have a branch in that code that would handle that exceptional behavior, bring it back into line, or either eject whatever the bad product was in this case. And so they were like, we think we can replace it with Airflow. And actually, we talked to them about it and said, yeah, I think it's a good fit.
Yeah,
because exactly what they were doing now is basically baked into an open source tool that if they really wanted to, they can extend and contribute back into open source versus maintaining this bespoke application that there's only a couple developers in the whole world who have built it, and if those people will leave, now you got to retrain people on how to build your in-house tool, as opposed to leveraging open source.
Right.
And now you've got the knowledge of the thousands or more who are maintaining Airflow itself.
Right.
I mean, that's a benefit of I think what Airbnb were the ones who created Airflow, and then open source that. So they went through all the pain and headache of having an in-house bespoke tool. But then saw how they could open source it and get a whole community now around it. And now it's become a really great, data orchestration or just a task orchestration tool in general.
Yeah. So like the benefits are, not only is there ongoing development of this thing, there's lots of test cases that have been out there, people using it,
right?
A community, a good set of documentation for this.
Yeah, great docs, and then there's great docs about extending it. So there's known, well-documented APIs for extending Airflow to talk to your own in-house system. So maybe you do have custom proprietary systems that are on the factory floor, and you need to interface with them. Well, Airflow has a nice UI or nice API for as a developer for you to build your own bridges between those sets of tools.
Cool. Yeah. Is this a common theme as a consultancy, potentially looking at existing open source tools to help out like a smaller shop to like say, well, you could implement this that is, going to do what you're trying to do. It may not be the perfect fit.
Oh, definitely.
Is that common for you?
Yeah, definitely. No, I mean, I think that's why people come to a group. Like 6 Feet Up is a consulting company, but we're a group of like senior engineers who are just super passionate about this kind of technology. And so we've seen a lot of different things over time. And so we also have played in a lot of different sandboxes over time as well, where maybe your in-house developers haven't been around the block, that many times and don't know that there are some, open source tooling or solutions already built that they can leverage to solve their problems.
Yeah. How small of a type of job would this make sense for? Like, is there like any kind of limitations there where you would switch over to the other kinds of things we were talking about before, like just sort of schedulers or other smaller tools?
Airflow itself is actually pretty straightforward and a nice tool that I think even if you were just playing with it from a hobbyist standpoint,
right? Which
I
is
think,
my audience potentially.
Yeah, right. You can, again, because it's Python, your first DAG, your first hello world DAG is probably going to be 10 lines of Python thrown into a folder. You don't have to think about how to wire it up or do anything special other than just write a create DAG function that has sets of operators in them, and the operators are kind of encapsulate the logic of your task. And some of the operators are pre-made. So if you've got, say you're doing home automation, and you wanted to do some kind of processing of maybe you got a camera on the outside watching for birds, you could take frames from that camera and send them over to a third-party SaaS software, and that's just a thing you could automate with Airflow.
Yeah. My example for that is a coyote right now.
Oh yeah.
We have
that's cool.
a pretty healthy coyote that's like hanging out outside our yard and passing by every other morning looking for bunnies. Unfortunately, for the bunnies, exactly.
So I think if you wanted to learn about it, it's really easy to dive in. There's great docs, there's great guides out there for you can actually just download the Airflow container and launch it on your Docker really quickly, and it'll have just a single hello world DAG in there, and that'll give you a feel for like, if I throw a file in this folder, it has these operators, in kind of look like tasks. And Airflow has a bit of, they've overridden a couple standard like Python operators so that you can kind of, it looks a little bit like ASCII art, kind of arrows here and there to like say, we'll go from this thing to that thing and to that thing. So it's kind of like a dash and a greater than, and it looks like you're making tasks linked to other tasks.
Yeah, definitely the flow chart feel.
Yeah, kind of a flowchart field. So that's probably the one thing that'll trip up some seasoned Python developers. They'll wonder what those things mean at first. But if the docs are really clear, the examples are really nice, it's a good way to get started.
Is the Django elements of it, is that something that you can sort of see as a seasoned Django person? You can say, I can see that, it kind of being hidden underneath the paint that is Airflow.
Not typically. I mean, as an Airflow developer or doing data engineering type tasks, I wouldn't think you would probably like dive into the Django guts of it.
Yeah.
Airflow itself is a framework around that, which gives you those kind of basic building blocks for making your DAGs, like the operators and the hooks and the connections. And there's some Airflow specific type building blocks that you would really use. It's just when you get into like debugging, being a Django dev, that then helps because you'll be able to step through and you'll recognize when you get into some Django code, like, oh, that's what's going on here. Whereas if you were just a data engineer, it may look a lot foreign to you.
Yeah. Okay. That makes sense.
Mm-hmm.
This week, I want to shine a spotlight on another real Python video course. Object-oriented programming is a method of structuring a program by bundling related properties and behaviors into individual objects. And this week's course is titled Python Basics Object-Oriented Programming. It's based on another section of Real Python's book, Python Basics, A Practical Introduction to Python 3. And in the course, Ian Curry takes you through how to create a class, which is a bit like a blueprint for creating an object. How to use classes to create new objects. Instantiate classes with attributes and methods. How to work with constructor methods. What are special methods, often called dunder methods. And a bit about how they can redefine how your custom objects behave with Python operators. Object-oriented programming can be a bit intimidating for someone starting on their Python journey. This course is a steady hand to lead you into the topic and includes just enough to get you going. And like all video courses on Real Python, The course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. Partly why we wanted to have you on again is to talk, this is our annual thing, talk about the upcoming Python Web Conference.
Yeah.
So what's going on this year?
Well, this year is the 5th year of the Python Web Conference. So it's going to be in March, 13th through the 17th. We have got a great lineup of speakers. We'll be announcing probably next week. So probably by the time this goes live, we'll have most of our speakers at talks announced. But we're looking at 5 days, over 50 talks, probably over 400 attendees. It's a very global event. We really love the fact that people come from like maybe 40 or more different countries to all come and talk about Python and do it online and virtually. We've been virtual since the start, since 2019. So before virtual conferences were even a real thing.
We're cool.
Yeah, we were the cool kids before that was the cool thing to do. But
exactly,
last year's event was very large. We're actually going to scale back the number of talks from last year just because it was a lot to handle.
Okay,
we had over 90 speakers last year, which was more than big conferences have. And we're only running with our little like team who handles doing some of the events here at 6 Feet Up. But yeah, it's going to be super exciting to have. The caliber of talks that I'm reviewing right now are incredible. It's going to be so hard to pick and choose. So we've had over 130 talks submitted for these, like for the 50 spots. So
50 spots. Okay,
yeah.
Wow.
It's gonna be hard to pick.
Yeah. One of the things that we talked about last year was the idea that it is during quote unquote a work week.
Yeah.
Which is kind of cool, and then it's sort of a half day thing too. Also, right? Those are some of the features of it.
It seems to be easier for folks to kind of say, I'm going to spend half a day on this and still be able to get real work done. That whole virtual work from home and, traveling to conferences traveling to conferences has been tricky, obviously, because of COVID.
Yeah.
But even for some people who couldn't travel for a conference, either it's just geographically unfeasible or outrageously expensive.
And travel is such a pain right now.
It is. Oh my gosh. Yeah. The news lately, you don't want to be getting on a plane right now if you can avoid it. So this gives people an opportunity to still get together, still have that community feel, but do it on I feel like on a format that allows them to make it a lot easier to say, I'm going to take off the morning and hit, Python Web Conference today. And I can do that a couple of days out of the week and kind of pick and choose what I want to see. Now, another nice thing with Python Web Conference is that once a talk is done, it's available for rewatch right away. You can actually see any of the talks that have already happened. They're all given live, but you have the ability to go watch, like if you had 2 competing talks in the morning or part of the day that you want to see,
which is common. Yeah.
In the afternoon, there's one you don't care about. You can actually like just go watch the morning ones right away. And so I think with the people from like 40 different countries and however many time zones we have, I think we had like 22 time zones accounted for. They're watching all day long and all night long for us. So it's really a 24/7 conference while it's happening. There's going to be a Slack channels, Slack org set up so that people can actually interact with each other. Kind of the hallway track of the Python Web Conference is really done in Slack. There's going to be a bunch of different social events going on that have been really popular. Last year we did an origami social. So we had one of our people at 6 Feet Up who's really passionate about origami do a whole tutorial, and we made snakes and a couple other like origami things all in person.
Nice.
All together over Zoom. And then we're going to do, a lot of other networking and social like fun activities throughout the week. And then the talks are more than just Python talks. We have culture talks. We're going to have big data talks. We're going to have a whole data track, a cloud track, and then a Python app dev track.
Okay. And then you guys, I think we talked about this before also, the infrastructure that for the conference is sort of homegrown, right?
It is. It's all built on Django. So the LoudSwarm virtual event platform that powers the Python Web Conference actually powered DjangoCon US last year and a few other conferences, is actually written in Django and hosted on AWS using containers.
Nice. So that's always one of those things, like people say, do people really use Python out there? It's like, yeah, we can do an entire like live hosted virtual conference.
Yeah. I mean, I think if it wasn't for the batteries included capabilities of Django, I don't think we could have gotten that thing off the ground as fast as we did.
Yeah, cool. Nice.
Yeah.
Do you have any conference talks coming up yourself?
I've submitted to a bunch of conferences. I know I submitted to PyCon and a couple others along the way. So I'll definitely be at PyCon this year in Utah. looking forward to coming together and seeing the Python community in person for those who can make it in person. But if you can't, Python Web Conference is a great alternative. And I don't know for the rest of the year. I may actually not go to as many conferences as I did last year, but I may substitute those for some other kinds of conferences. So whether it's, we're doing a lot more around climate action, clean energy, and kind of like do-gooder initiatives for things that benefit humankind. And so I think I may be spending some more time at conferences like that.
I would be very interested in hearing more technological talks in those veins, because it just seems like, if we could get past the whole financial grab thing of crypto and whatever, it's just like, can we do something different here? So
there's a lot going on in that space, and as part of, I don't know if I talked about it last year, but 6VF has dedicated a 10-year target for us to do impactful work in the world, and so we actually want to have projects that have meaningful results and can benefit humankind, and that's part of our goal and our initiatives and our intentions for the new work we're taking on. And so I'm really gotten into what kind of do-gooders can we go out and help. I mean, there's still tons and tons of work to do in these areas.
Yeah, cool. That's awesome.
Yeah.
How can people keep up with the work that you're doing online?
Sure. You can follow me on Twitter, although I'm less and less there, as Calvin HP.
Yeah.
Probably the best way to follow what 6VF's doing and some of the work, these kinds of things where we typically try and blog and talk about the kinds of technologies we're working on at a pretty frequent basis.
Okay.
You can find that at 6vf.com/blog. There's a whole bunch of cool articles and stuff there. I'm definitely on Mastodon. So I am Calvin HP at fostodon.org. So you can catch me over there. That's probably the place where I'll be putting more of my personal tech content on there.
Yeah,
that's probably the best way.
I've been enjoying Mastodon and Fostodon. It's been much more conversational, and
it's the old days back again from Twitter.
I
really feel like
I missed Python, that too.
I feel like the Python community really embraced it too, very, very quickly.
Yeah. It was like quite almost like a light switch. Okay, we're done.
Right. See you, Twitter. Hi, Mastodon.
So that's been cool. You have a local user group there in Indianapolis.
Yeah, we're celebrating 15 years this year for IndyPy.
Oh, wow. Cool.
Yeah.
Any recent stuff you want to talk about there?
We just had Mariatta from the Python core devs on talking about how to be a Python core dev.
Okay, awesome.
Surprised to me, you don't need to be a C or C++ developer at all to be a Python core dev. And that was actually a big revelation to me. That talk will be online on YouTube. So if you just search up the IndyPy on YouTube, you'll be able to find our most recent talk from her.
Okay.
We've got all kinds of content as well from IndyPy up there over the last, we've started recording those probably for the last 5 or 6 years. We've been putting all of our monthly meeting talks up online.
Yeah, might be a good example for people that are interested in starting their own group.
Yeah.
The types of things that you can do and guests that you could actually reach out to and maybe get.
Oh, yeah. No, we've had so many great speakers over the years. I mean, doing it for 15 years, you run across a lot of people doing very interesting things. Actually, you have some of the people you've mentioned, like Al Swigert has been one of our speakers.
Oh, awesome. That's cool.
Yeah.
I have my weekly questions.
Okay.
The first one is, what are you excited about in the world of Python?
Right now, I'm excited about Home Assistant. I've been diving into home automation probably for the last 10 years. But recently, I guess in the last 3 or 4 years, I switched over to Home Assistant from a proprietary home hub thing.
Okay.
And for those of you who don't know about Home Assistant, it's basically a home automation software all written in Python, and it's all open source. And you can install it onto a Raspberry Pi or...
That's what I was thinking. Okay.
Yeah, some other kind of device. I actually run it in a Docker container on a little Intel NUC thing downstairs in my basement. Because as soon as you get above a certain number of devices, you're going to need a little more horsepower for it. But it's all async. It's actually a really good example of Python and async, and because it has to track so many states of so many different devices in the house. Like, for example, I've got Hue light bulbs and quick set door locks that are hooked up to it over Z-Wave, and I've got a Sense on my power box. So all the circuits are monitored, and it uses those as sensors as inputs to the system.
Interesting.
So you can write all kinds of automations based on, well, when the boys' bathroom light goes on, maybe you need to tell Alexa to say something, to tell them to shut it off or whatever. Or if you've got those hooked up to a Hue lights or whatever, one of the automations I typically set up is after 11 p.m., anyone who walks through the main living space, there's a motion detector hooked up to the alarm system. And I use that sensor to turn on the kitchen counter light.
Yeah.
And so you don't have to worry about turning the light on when it's all dark. And then you can just keep on walking and it automatically turns it off 3 minutes later.
Nice. Okay. Just set a timer of sorts.
Simple little triggers and timers. And I use it to turn on the Christmas lights outside, during Christmas time and turn it all off. And so you basically can use it to monitor and help you understand the usage of energy in your home. And I really like it. It's a really cool project. I've rented a couple of the folks at conferences over the years. So I know a couple of people who are, working on the project, and it's really cool. They're very, very active, constantly adding all kinds of new home automation gimmicks and gadgets and stuff to the project. So, I mean, at some point, I think I'd hook my car up to it. You can actually hook up,
Okay.
if your car has a cloud account, you can tell like when the doors open and the doors close and the level of the gas and like all these kinds of things on your car. It's amazing what the IoT has brought to the home.
Yeah. I have a handful of devices, some that are friendlier than others, trying to get them going.
Oh yeah, gosh, there's the varying degrees of quality there for sure.
I have a bunch of Wemo stuff, and I'm kind of like shaking my head at it sometimes. Like I feel like they want their own standard to be out there, but I will definitely look at it. And then it supports like all sorts of different devices and everything, like thermostats and the whole.
Thermostats, switches, sensors. I mean, and what's nice is if there's something you want it to support and it doesn't, it's Python, so you can actually just write your own add-ons. There's a whole open source like add-on store that people write their own extensions to do things that aren't in the kind of core of Home Assistant, but the core itself has just a ton of stuff built into it. It's really incredible.
Okay, cool.
Yeah.
And that's getting you actually writing some Python. We were kind of talking about that before we started.
Right. Because I think more and more I'm trying to write less and less Python for work. I'm trying to do more kind of leadership of the team as we scale and grow 6 feet up. So for me, Home Assistant is actually what I'm excited about because I get to write some Python on a personal level.
Yeah, exactly.
Mm-hmm.
So the next one is, what do you want to learn next? And again, doesn't have to be programming or Python specifically. Yeah,
I'm really, really curious about some of these synthesizers. My brother has bought into the whole Eurorack modular synth stuff, and that's quite a rabbit hole. But I was asking him, if I wanted to start playing around and just having something make some beeps and boops and sounds, like what should I get? And he had suggested to me the Arturia Microfreak, which is a cool, it's like about $300. Little synth with a sequencer built in. I think it's got like 6 voices. So it's enough stuff that you can really make interesting things, or it's enough stuff that you don't have to know a lot to get it to make interesting things.
Yeah. So arpeggiators and all kinds of fun stuff.
I'm trying to find like some spare time to figure out when I would do that. So I've not pulled the trigger yet, but that's what I would love to learn some more about making music. Well, my oldest has actually picked up the guitar recently and started playing and learning guitar. And so he's kind of inspired me a little bit to be more of a creator than just a consumer of music.
Yeah, cool. Yeah, I love their stuff. I have all their software plugins, I swear. I was telling you about this one I really love called Pigments. It's just a really great software synthesizer that just amazing sounds. Just even if you can't play like a classical pianist or whatever, you can just hold down some chords and it'll just amaze you with the kind of sound coming out. It sounds like a soundtrack.
The big ethereal type sounds you can get out of these things.
Yeah, it's very fun.
Yeah, no, that's what I like to learn next.
Yeah, nice. Well, Calvin, thanks again for coming on the show. It's always fun to talk to you.
Yeah, no, I always love coming out and hanging out with you.
All right, talk to you soon.
We'll talk to you soon. Thanks.
And don't forget CData software, simple cloud data connectivity to SaaS, big data, and NoSQL. From Pandas, SQL Alchemy, Dash, and Pedal. Learn more at cdata.com. I want to thank Calvin Hendryx-Parker for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.